from the array?
No, sorting. It's just sorting, but there's different types of algorithms for sorting. Some are more efficient than others. They have similar techniques, but this one has a very particular one. Um,
Okay, so I just gonna tell you guys. Okay, so I'm gonna teach the quick sort technique. It's quite complicated. Okay, so I gonna just give a overview first. So that's we're gonna first pick a number. So okay, do I need to read the question? I can read it one more time. So it's write a function that is the same as last two sessions. It's the same array, same output, but we use different technique and a different sorting algorithm. Okay, so write a function that takes in an array of integers and returns a sorted version of that array. Use the quicksort algorithm to sort the array. So the given input array is unsorted, then the sample output array need to be sorted, which is from the smallest number to the largest number. So for this, I'm gonna give like a overview, like a kind of like a logic, like a quick logic. So first we're gonna pick a number called the pivot number. Do you guys understand what is pivot number? So basically a pivot number is kind of like a number as a standard. Then you kind of like refer that number like compared to other numbers in, like for example, this is input array, right? So we randomly pick a number as our pivot number. It's kind of like a standard number. Then we compare the rest numbers with that pivot number. Is it smaller or bigger? Okay. So for example, if here we pick our pivot number like the index at 0, which is 8, then we're gonna compare the rest of the array, all the numbers with that 8. Then we're gonna switch positions according to the largest or smallest value. Okay, so that is if the number smaller than that pivot number, then we're gonna move the number to the left. Can you guys see my mouse? To the left, the period number. Then if the number bigger than the period number, okay, so for example, if we pick a period number randomly, we don't pick 8. Let's say we pick 9, okay? So we're gonna compare all the numbers, the rest of numbers to that period number. So for example, like this, we have 2 sub-arrays, which one is left sub-array on the period number, and the one is right sub-array to the period number. So we're gonna compare each numbers in the left sub-array and the right sub-array to the period number. So for example, if this number is smaller than the period number, then we move that number to the left of the period number. If it's greater than, then we move that number to the right of the period number. So that is the logic. Then we're gonna repeating the whole thing. Then we're gonna repeating the whole thing. Then we do like one round, and the second round we're gonna pick another period number. Do you guys understand? Devil already sleepy. We haven't started yet. Okay, so okay, doesn't matter. We're just gonna problem walk through then. Problem walk through. Bunny, do you have anything to speak?
No.
Okay, so let's do a problem walk through so everybody will understand. It's gonna be very long, okay? So please be awake. Okay, let's do it. It's gonna be 12 rounds. Okay, so I just gonna logic or method. Okay, so step 1, we're gonna pick a pivot number. Ray, can you explain what is pivot number in English? Yes, he's still there.
Yeah, a pivot is a point where you are going to be, I guess, where you decide where you're going to divide. It's like a dividing point, right? Stuff that goes to the left. The pivot is the middle, right, of your arrays. So if it's less than, then you put it to the left. If it's greater than or equal, I guess you go to the right, or you could do less than or equal. I don't know, whatever you choose. But the pivot is the inflection point of, or dividing point of your two separate arrays. I'll just call it a tipping point. I don't know, whatever.
Okay, we're gonna walk through it, because if I tell step 1, step 2, you guys don't understand. Okay, so okay, first step, we're gonna pick our pivot number, right? So round 1. Also like the first pivot round 1.
It's not number, it's your index.
No, pivot is gonna be the number.
Oh yeah. The number, get that index. Yeah.
Okay, round 1. Okay, we're gonna do 12 rounds, so please stay awake. Okay, so step 1, we're gonna pick the pivot number, right? Pick the pivot number. I just say P now. Okay, so for example, if here we're gonna pick our first name when pivot number equals 8. Do you guys know the input array is this? Okay, so our pivot number will be the 8. Then we're gonna iterate the rest of the values. So we pick the first value as pivot number, then we're gonna iterate through the rest of values. You guys understand? So we're gonna iterate through from 5 to 3. Okay, then we're gonna init the pointers. Because we're gonna init pointers to, so once we have pointers, because pointer is pointing to the index number, so once we have the pointer index position, we can get the value. Then we can compare that value with the pivot number value. Okay, so step 2 is iterate through the rest of array. Then step 3 is init pointers. Okay, so how we gonna init pointers? So let's say this one 1.8. So it will be, we have a pointer called a P pointer pivot. We're gonna point to the 8. Okay, so we're gonna be 8. Then we have left pointer. It will be 5. Then we have right pointer. It will be 3. Do you guys understand that? Does anybody do not understand the pointers? Okay, if people don't understand, then just speak out. If not, then we're gonna continue. So our okay, hold on, let me see the screen brush. Okay, so this is our pivot number P. Then we're gonna make these as left pointer, and these will be right pointer. Okay. Yeah. So that's it. Okay. Then we're gonna iterate. Okay. Then we're gonna 1.3. So once we have the pointer initiated, then we're gonna iterate through the rest of the array. Okay. Then we're gonna ask some questions, like before, question to ask. So we're gonna, so the goal is, we wanna first put all the numbers, all the smaller numbers to the left of the previous number. So we want to accomplish this goal. One is mission to complete is put all the smaller numbers to the left of the previous number after we compare. Second is put all greater, which is bigger, right? Greater numbers to the left, not left, to the right of the previous number. Okay, so that is our goal. That is after we iterate the loop, then that is all we need to do. That is the logic. Okay. Yeah. So we're gonna start comparing now. We're gonna start iterate now. Okay. So let's see. Iterate through the number. So do you think we need a while loop? Because we need a while loop to make sure all the right pointer index will be greater than left pointer index, right? Do you guys agree?
Are you asking us or are you telling us if that's what we're using?
To make sure all the right pointers will be greater equal. So all the right pointers will be always on the right of the left pointer. Okay. Okay, so now we're gonna start to iterate. Okay. Okay, so we're gonna ask a question. So the first question is our number at the left pointer greater than the previous number?
No.
Okay, so what is our number now? So first iteration, what is the current now?
Which number is the current number? Are you talking about our pivot as the current number or our left pointer as the current number?
No, because right now we start our iterate is from here to here. So what is our current now?
5.
5,
Yeah.
right?
Yeah. So this is the left pointer and this is the right pointer. Okay, so is it left pointer now greater than the previous now? So left point now is 5 and the previous now is 8. So that will be no, right?
Yes.
Okay. Then another question to ask is current now at right pointer smaller than period noun. What is our right noun?
3.
Yeah. Okay, so period noun is what?
8.
8. So yes, it's 3 smaller than 8. So that is yes, right? So yes, then we're gonna so yes, we're gonna swap the two numbers. Let me see.
So,
Oh no. We're gonna move the left pointer to the right, right?
yeah, so we only swap numbers in the while loop once either our left and right pointers are crossed, or both our left and right pointers are in the wrong place. So if one pointer is correct and one pointer is wrong, we do not swap.
Yeah. Okay. Okay, so we do not swap, and we move left pointer to the right. Okay, so that will be round 2. Okay.
Okay, so is everyone kind of, just to recap what happened, basically in our first loop we check to see if our left pointer is less than our pivot, and if our right pointer is greater than our pivot. And if our left pointer is less than our pivot, that's great. We don't really worry about it for now. Our right pointer, if it's greater than our pivot, then that's also great. We don't worry about it for now. But if we find a number that's out of place, then we will stay there. I'm looking for help, but we'll stay there basically until we find a number we can swap it with. If one of the pointers meets our conditions. So in the case of 3, our right pointer, we want all the numbers to the right to be greater than our pivot. So because our right pointer is smaller than our pivot, we're going to leave our right pointer there until we can find a number that we can swap our pivot with, or that we can swap our right pointer with.
Okay, so we're gonna, for the round 2, so remember for the first round, we already moved our pointers. We moved our left pointers, before was 5. Hold on. Let me see. Before was 8, 5. Yeah, it's right. Okay, before was left point is 5, right? And the right point is 3. Then we move our left pointer to the right. So our left noun is 2, and the right noun still 3. Right pointer still here at this index, and the left pointer move from this position to the right by 1. Okay, so basically, if the condition now is like this, so if the left noun are smaller than pivot noun, and right noun are smaller than pivot noun, then we do not swap the position, and we move the left pointer to the right by 1. Okay, so that is one condition. Well, I don't know why, but this is the technique. But
Are
unless
you
people can say why,
are
like
you asking the question why we don't swap it yet?
yeah.
Why we don't swap what with what?
So why this condition is why these two conditions are met? Let's say it's right both ends. Then why we don't swap and move the left pointer to the right?
So 5 is less than 8. That's great, but 3 is not greater than
Yeah,
8
8.
because we do not know if 8 is our largest number in the array or not. We want as few swaps as possible. We're only comparing things according to our pivot number. So we don't want to move our pivot number around until we know exactly where we want it to go. So so you're adding more calculations if you're swapping the 3 and the 5 and because we'll eventually sort those out later. We only want to swap what's absolutely necessary. So unless both pivots are in the wrong, unless both pointers are on the wrong side of the pivot, that's the only time we swap. Otherwise, we wait until we find out what the absolute largest number is, and in our first pass, the absolute largest number will be at the end of our array, and then we will know where our pivot should go. It just ensures that we don't do too many swaps until we find out what exactly the last number, until exactly we find out what should go at the end of the array.
Do you guys understand? Why you guys frozen everybody? Okay, if you guys don't understand, we just walk through many rounds, then you will understand. So first,
No.
we pick
Sorry.
step 1. We pick a pivot number. Then we gonna sort algorithm. Then we make the pivot number to be a perfect position, and that perfect position, the pivot number will not move. Just stay in that position. Then we're gonna move other numbers, but that pivot number just perfectly find its perfect position. Okay, we will see after we walk through the problem. Okay.
Just to quickly answer that question in the chat. So, when the index of the left pointer, when the index of left is greater than the index of right, then by that time, yes, we should know. We should at least in this case, we should know what the largest number of our array is. That array should be at the end, and then we should be able to keep track of where our pivot should go. Basically, by the end of the first, by the time that left is greater than right, all we should need to do is swap our right with our pivot, because all the numbers greater than our pivot will already be to the right. So that's why we do that.
Okay, so if you guys don't understand, just don't freak it out. Just follow the steps and train yourself to think like this, because this is how the QuickSort works. Okay. Okay, Ashwin, we're gonna ask, is left noun greater than pivot noun now for the round 2?
No.
Okay, what is our left noun?
It is 2. Left is 2.
Yes.
Right is 3.
What is the pivot noun?
8.
8.
Pivot is 8.
Yes. So that was greater, no, right?
Yes.
Okay. Then what is right now?
3.
Yes. Okay. What is the pivot now?
Pivot is 8.
Okay. Is 3 smaller? Yes.
Yes.
Okay. So if that is the case, so decision making, are we swap or not swap?
No swap, I think.
What?
No swap, I think.
No swap.
Do not swap, right? And so okay, what are we gonna do?
Move our right pointer one.
Continue.
Yeah,
Move to the
we're gonna move left pointer
Left
to
pointer.
the right. Okay. Right by 1. Okay. Okay, so we're gonna become round 3 now. That's pretty good. Okay.
Does everyone understand what's kind of going on? Basically, all our loops are doing are searching for numbers that are not on the right side of the pivot. All our left pointer does is search for numbers greater than the pivot, and if it does, it stops there. If our right pointer looks for numbers less than the pivot, and if it finds one, it stops there. So that way, when both conditions are true, and both left pointers and the right pointer have the wrong number, then it can swap them. And it just keeps searching for that until it works its way till they cross. And then we move our pivot, and then we start over with a smaller and smaller array each time.
I think they will not understand until we find the perfect position.
I
Then
don't
you
understand
guys-
until I keep explaining it, so it's
Yeah.
fine. Doing this for me.
So the thing is, you never know because you never encountered it before. Until we experimenting, then you know. Okay, that's called the never try, never know. Once you try, you know. Okay, just experimenting the algorithm, then you know. Okay, that's pretty much it. Okay, so for round 3, we still not swap anything, right? So our array still like this, like the same as given input array, right? Okay, so we're gonna still do that one. Okay, so we move left point to the right now. Okay, so who gonna tell me? I pick Sandon. So then, what is our round 3? What is our pivot num? Then.
Yes, our pivot number is pivot is still 8.
Yes. What is our left num?
Now left is moved to the 9.
Yes. Does anybody do not understand? Because we are like round 2 is 2. Then we move to the right. Then left num become 9 because left pointer increment by 1. What is the right num?
Right is 3.
Yes, 3. Okay, so what is the procedure?
We need to check the condition first.
Yes, left num are greater than pivot num. Okay, so what is left num? Which is 9. Greater than pivot num?
Yes.
Okay, so yes. Okay, second question, yes. Okay.
Right now.
Yes, so right now smaller than pivot num.
Yes.
So right now is 3, right? Pivot num is 8.
Pivot is 8.
Okay, so when it both yes, what we do?
So we go inside the loop. I don't know what will happen after that.
So yes, so if that is the case, we're gonna swap. Okay. So look, once you walk through the steps, you will know. Okay, so when the condition is no and yes, then we don't swap and we move left pointer to the right, increment by left pointer plus plus. Then when condition is yes and yes, then we swap. So that is how you write the code, you know. Okay. Okay, so decision making. Decision making. Decision making is swap, right? Okay, how we gonna swap? Cause so QuickSort has many different kind of swap, but for this we're gonna swap right now. Swap the position of right now with left now. Okay. So we're gonna update our so after swap, right? Swap.
Yes.
Then it become okay 8. So
5.
no, right now with left now. Okay, tell me what is our left now? Okay, so tell me before we swap, what is our left now?
Our left num was 9 before I swap.
Yes. And right now is 3, right? So we're
Yes.
gonna become 8, 5, 2, 3, 5, 6, 9. Okay.
Yes.
So it's not swap 5 and 3. Okay, it's current the pointer, the left pointer with right pointer. Then this round, which is pointer to the left now is 9 and the right now is 3. Okay, so be careful with that.
Thank you.
Yeah. Okay, so that is how magic happens. And this is our first swap. Okay. Can you guys please help me check is it correct? Swap the right?
Yep.
Yes.
Okay.
Right.
Okay, good. So we finish the first swap, right? Okay, then we're gonna move on. Okay, move on. Okay, move on. Okay, so we're gonna move on to the round 4. Okay, round 4. Okay, as long as you guys still awake, I am happy. You know.
We are awake. We are awake. It is morning here, so for me, no problem.
Yeah. Okay, so hold on a second. Eee. Okay, so I don't know. The heck? Okay, first period. First, now, round. Which round are we now? Round
2.
No, it's not round 2. Round
3.
4. Round 4. Yeah. Okay, so round 4, we got this. And so that is the beginning of round 4, right? Okay, so step 1, we're gonna unit our pointers. Not unit like just remember what is our pointers. Okay, tell me. Okay, tell me what is pivot number for round 4. I choose Saddam. You choose another person. Continue for you.
Which one?
So do we need to choose a new pivot number or continue with the same pivot number?
I ask you.
So since we made a swap, I think we can choose a new pivot number.
Okay, okay, sorry. I just tell you, we just still these. Okay, so I tell you when we're gonna choose different pivot number. That is once we found the first pivot number's perfect position, then we choose the second pivot number. Okay. So we have not found the perfect position for the first pivot number, so we will not change that pivot number until we finish that pivot number. Okay. So our pivot number is still 8. Okay.
8, yeah.
Yeah. So what is our left node now?
It's 5.
Huh?
5?
No.
I thought we swapped.
Okay, I'm
3.
You do next round as we Saddam.
Yeah,
Because he swapped. He know. Okay, Saddam, continue. What is our left noun now?
So we swap between 5 and so we move to the 6. Our left should be 6 now.
No, wait. Remember before we move 9 and 3. Remember?
Yeah, I remember now. Yeah.
This is 9, this is 3. So we did not move our left pointer to the right yet. So what is our left num now? Left pointer.
3.
Yes, still 3, right? Because we did not
Yes.
move.
Yes.
Once we swap, we don't move. If we don't swap, we move. Okay. Then what is the right num now?
Right is 9.
Yeah, because we swapped, right? Okay.
Yes.
So now that is our current situation. So now we're gonna ask questions. Okay, so the question still, what question we're gonna ask?
Is the left one smaller than the pivot?
So yes, left noun greater than. Don't
Greater
do
than the pivot.
opposite. Opposite you will be wrong.
Okay.
Yeah. Okay, so yes, what is left noun?
Left is 3.
Yeah, pivot noun 8.
Yeah, and pivot is 8.
So that is no, right?
That is no, yeah.
Yeah. Okay, what is right now?
The right is 9.
What
And
is
pivot
pivot
is
now?
8. Pivot is 8.
Yes, yes or no?
No.
No.
Okay. So once it's no, what we gonna do?
We move the left one step and
7, do you know?
Move the left one to the right and the right one to the left. Wait, are you asking about the pivot still?
No. Okay, we are asking right now. Situation is left noun is smaller than pivot noun and right now. So these two positions.
Left num is smaller than the pivot and right num is greater than the pivot. Then you do nothing, you just move both. You just move both pointers over.
Okay, so if that's the case, we do not swap.
No.
yeah.
You just happen to you just move both pointers instead of
And
just one.
yes, action yes, we're gonna action 1, we're gonna increment, we're gonna move, hold on, move left pointer to the right by 1 and move. So this is the same time, okay? Move right pointer to the left by 1. Okay, so once we get this, we're gonna update the. Okay, so what we got? Okay, so we did that one, right? So we're gonna move to the, because we did not swap, so we're gonna move to the wrong side. Okay. Wrong side, what is our array? Okay, so that is our array. Then we're gonna unit our pointers. Okay. I'm gonna pick up lady. Yes, any lady to do here?
Yeah, you can do it.
No. That's it. You wanna try? Jeffrey, are you there? Okay.
Yes, I'm.
Okay. Are you still awake?
Mm-hmm.
Okay, so you continue. What is, so after we did the 4 rounds, what is our current situation? What is pivot num now?
Do we need to change the pivot number? Because the previous 8 is the pivot number.
No, because we did not find the perfect position yet. Once we find the perfect position, I let you know.
Okay.
Yeah.
So still our pivot number is 8.
Yes. Okay, what is our left noun now?
5.
Yes. What is right noun now?
9. Mm-hmm.
No, 6.
No, 6.
Because remember, like last time, we move the left pointer to the right and we move the right pointer to the left.
Oh, okay.
Yeah, I ask you after we move the 2 pointers, what is our left noun? Left pointer to which noun? So round 4, right? We are round 5. Round 4, left pointer is 3, move to the right, become 5. Right pointer is 9, move to the left, become 6.
Become 6.
Yeah, okay. So now we are like this, okay? Got it? That's why I don't draw graph. If I draw graph, everybody knows because you just read, but you don't know how difficult when you move pointers. Okay, so we got that one. Then what we gonna do next? Do you know, Jasmine?
If the 5 is greater than pivot number.
Yeah, we're gonna ask questions. First question is we're gonna ask this. Okay. So we're gonna ask. Yes, the left noun is greater than. Okay, left noun is 5. Previous noun is 8, right? Is 5 greater than? No. Okay, right noun smaller than left previous noun. Right noun, yes.
Yes.
Six.
Smaller
Yes.
than.
So that is yes.
Yeah.
Yes.
Okay, so one no and a yes. What we gonna do?
Move our left pointer.
Okay, so that was, let me look. So we gonna increment. We don't right?
Yeah, we don't
And
follow.
we move our left pointer to the right.
Next number. Okay.
Yeah. Okay, so
Now,
okay, so now we become round 6. Okay. Okay. Maybe I choose Joe to continue. So Joe, after we move the left pointer to the right, what is our left now? What is our right now?
Left noun would be 6.
Yeah, because that was left 5. Now we move to the right, is 6. What is right now?
Right noun would be 5.
No. Huh? Right now, let me see. Right now, 6. Because right now we did not move
Oh,
to
sorry.
the
Yeah. We did not move. It's still 6.
yeah, 6. Okay. Okay, so here is the problem now. So, okay, I know spring brush. So, current situation is previous noun is that one, right? So, left noun. So, right noun is 6 in round 5, right? Right pointer. Then, in the round 5, left noun, left pointer is 5. Now we move left pointer to the right, become round 6. Now our left pointer becomes 6 too, left pointer. So it's overlapping.
Right.
Now it's overlapping now. So if it's overlapping, what we gonna do?
can we swap the pivot number with that position? So because that's the ideal position for the pivot number.
Yeah. So this is I just tell you right now we're gonna make like a draw. So right now the 2 pointers are overlapping, but the question to ask are still same question. Still the same question. Yes, the left noun are greater than the previous noun. Yes, the right noun are smaller than the previous noun. It's just the left noun and the right noun are same noun now. Okay. So and so we're gonna ask the procedure still the same. I just draw that one so everybody like know what our current situation is. So the procedure still same. Question to ask is left noun are greater than previous noun. So our left noun is 6, right?
Yeah.
And that is no. And the right noun is 6 too, because we are same like overlapping. So left noun equal to right noun. So that is yes. So that is no and yes are same as the previous no and yes. So what we do?
We move left
We
pointer.
move the left num by 1.
Yeah, do not swap, right? It's
Yeah,
the
do not
same.
swap.
Yeah, do not swap. And action is move the left pointer to the right by 1. Okay. So now we become this. Hold on a second. I'm gonna do that one. Okay, we almost have perfect position soon. Okay, so that is this. Since we did not swap, so the number and the position still stay the same. It's just the pointer changed, right? So what is previous noun now?
Still 8.
Yeah. Okay, so what is our left noun now?
9.
Yes, because we moved the left pointer to the right. What is our right noun now?
Keep it.
Huh?
Same number.
Yes, still
Keep it.
6, because we only move left pointer, we did not move right pointer, right? Okay,
Right.
so I'm gonna draw it. Yeah. Okay, so right now, this is our right pointer, right. This is our left pointer. But remember at the very beginning, we have to make a left pointer always smaller or equal than the right pointer. So always on the left of the right pointer, right? So do you guys understand when we write the while conditional scoping? The left pointer will be always smaller or equal than the right pointer. So the left pointer should always smaller than the right pointer on the left, or the maximum is equal. So to this point, to this moment, we done because it's not in the conditional anymore, because this is the condition. So we okay. So if that's the case, we're gonna find our perfect. We're gonna find our perfect position soon. Okay. Let me look at the note. Okay. So I just tell you that I'm gonna draw this one. Then I'm gonna erase. Just make sure everybody remember. Okay. So the previous noun is 8. Everybody remember our current situation, okay? I'm gonna erase and we're gonna do the question to ask same procedure. Okay, so we're gonna just forget about that one, then we're gonna same ask the question. Ask the question. So question is left noun greater than previous noun? Left noun is 9. Right?
Yep.
Previous noun is 8.
Yes.
So that is yes. Okay. Is the right noun smaller than pivot noun? What is our right noun? 6,
6.
right? Okay. So pivot noun is 8. So yes. So when both are yes,
We swap.
yes, we swap. Okay. Hold on. Let me.
Wait, what are we swapping?
Oh, hold on a second. Let me take a look. I need to take a
So our
look
left pointer
on my
is
notes.
9, and our right pointer is 6, correct?
6. Yeah.
Our while loop should have ended by now.
Yes. Then we're gonna swap
But what are we swapping?
because the pointers are overlapping.
What are we swapping?
Okay, so that is the exciting moment. We're gonna swap the pivot noun with the right pointer noun. That is the exciting moment. Then we find our perfect position.
Right, exciting moment. It makes it less exciting. Look at the moment.
Like after 7 rounds, we find the perfect position of the pivot noun. Do you understand? Okay, so we swap. Okay. Decision making. So we swap, but we don't swap right now and the left now. We swap pivot noun and the right now. Okay, so because left noun already out of scope, so we don't need to think about left noun anymore. We're gonna just focus on the right noun, because right now is the end of the array of scope, the noun and the pivot noun. Okay, so decision making is swap. Are you guys excited? I mean, I am pretty excited, you know.
I'm so excited.
Huh? Who's excited?
Me.
Let's get ready to swap.
Okay, tell me, we swap pivot noun with which noun?
With right noun 6.
Yes. Okay, I'm gonna ask you already. I'm gonna ask somebody pay attention and why it's right now. Ashwin, did you follow?
Yeah.
Okay, why we swap pivot noun with right now, not pivot noun with left now?
I think we're swapping it when both of them, like left num and right num, are at 6. So
Okay, so then you answer.
We have found the right place for the pivot, right?
Yes.
Yeah, that's why, because we have found the right place for the pivot.
No.
So we need to swap now.
Okay, so tell me why we swap pivot noun is 8, right?
Yes.
Okay, pivot noun is 8, and right now is 6. Last time now is 9. Why we swap 8 with 6, not 8 with 9?
Because initially we decided that all the numbers that are greater than the pivot noun would be to the right, and all the numbers that are less than to the pivot noun would be to the left of the noun.
Yes, correct. Also, another thing is when we write while loop, remember I jot, the left pointer will always on the left to the right pointer. So right now the left pointer 9 already on the right of the right pointer, so it's not qualified anymore. Okay, so this is our right pointer, right? And this is our left pointer. This is not qualified because left pointer, the maximum is overlapping on the right pointer. You can never pass the right pointer. Then the loop ends. Loop ends here is met the condition. So we cannot swap pivot noun with the stuff is not in the scope,
So
you know. So we just this and this.
so yeah, kind of to
And then
reiterate that.
plus due explanation, we need all the numbers greater than the pivot noun on the right of the pivot noun. Then, so we need to meet two requirements. Okay. So the 9 is not qualified for swap. We can just ignore that one. Okay, we're gonna swap. Okay, that's pretty exciting. 5, 2, 3, 5, 6. Oh no.
8,
6, 5, 2, 3, 5.
8,
We
9.
swap. Yeah, 8, 9. Okay, now I'm gonna draw that one. Now the 8 is perfect position. Perfect. So you will stay there. Don't move. Okay? Sorry, So look, look. Okay, so now we're gonna divide. So now we have an array, the left, and the array on the right. It's called a subarray. Okay. So since here it's just our scenario, the subarray. You know subarray, right? Subarray. So the subarray only has one element, but it just happened to this problem. But for other problems, subarray has 3 elements or 4 elements or whatever element. Okay. So, but the key thing is our pivot now is gonna be always stay here because it's the perfect position. So when we do sorting and move position and swap, we will swap the numbers here, change position, or here change position, but we will not move the pivot noun position. Okay, got it? We find the perfect position for pivot noun. Okay, so now we're gonna now it's getting complicated. Now we're gonna loop through the left subarray and loop through the right subarray. Then we find the pivot noun in the left subarray and find the pivot noun for the right subarray. Then we find the perfect position for the pivot noun in the left subarray and find the pivot noun perfect position in the right subarray. Got it? So don't blow his mind. That's why it's hard, but it's pretty clear. It's just have like 6 rounds to go. Okay, just pay attention, don't sleep, and we're gonna find the perfect position.
Yes.
Okay, we're gonna continue, or you guys wanna rest a little bit? I'm gonna have some coffee.
Did we get nap time?
What did you say?
I want nap time.
Okay, whatever, you can use the restroom. Okay, I'm gonna write the accomplishment. Okay. Ashwin, are you excited?
Yes.
Okay.
I just have one doubt. Like, why do we need around 7? It already exceeds the left pointer, and that violates the while condition, right? How do we go to round 7?
Okay, who can Devin answer him?
You're asking me what now?
Like in the previous steps, like Jennifer was doing like rounds 1 to 7 for each iteration. So on round 7, the left pointer like exceeds the right pointer. It comes to the right of the right pointer. So I don't think we need to go to that step, right? Like we can probably stop at round 6 and do the swap.
Well, first of all, so you're saying we don't need that extra loop to determine the swap?
I'm just thinking that if like left pointer comes like to the right side of the right pointer, then it violates the while condition.
Yes, correct.
So how do we go there? Like, and I'm assuming we have to swap before we exit the while.
So yes, there is still one more pass when the left and right are overlapping before it exits the while loop. If that's what you're asking, yes.
Yeah. So do we swap when they overlap, or do we swap after they like cross each other? Are they allowed to cross each other?
We swap when they cross each other.
Okay.
So as far as assuming you're looking for the specific why, as far as why can't we just swap it one loop earlier?
Mm-hmm.
So that is a valid question. I'm not gonna lie. I do not know the answer to that at this exact point in time. I'm positive there's an edge case. There's always an edge case, but I do not know what that edge case is off the top of my head. I am not going to lie to you.
Okay.
Just know there's always one.
Yeah.
My guess is it probably something to do with the pivot and one of the pointers being the same number. Like I couldn't honestly tell.
Mm-hmm. Okay.
So are you guys gonna pick a second pivot now? Okay, I'm ready.
Goodness.
Anybody wanna use restroom?
I only want to use it when it's my turn to go.
Okay, is it your turn now? I mean,
know.
okay, we're gonna pick second period now, okay? Well, that is how algorithm is. Algorithm is boring,
Don't say that. It's a fun and exciting world of problem solving.
But after boring journey, then we find the exciting moment. If there is no boring, you don't feel the perfect position of period now is exciting, Okay, so we're gonna second period now, round one. Step one, we're gonna pick the pivot now. Okay, so one thing we're gonna remember. Okay, I'm gonna put that one here. I put that one just right here. Okay, so I put this. This is first perfect position of pivot now, right?
Yes.
Of first pivot now. Okay, so we're gonna here. Otherwise, you guys gonna not remember. So remember, I said this stuff don't change. Then we're gonna iterate through the left subarray and the right subarray. So since the right subarray only has one element, which is 9, and that one is greater than the period num, so we don't need to do that one anymore. It's good. So we can update the second perfect position for the 9 is here. So right now we have 2 perfect position numbers. You understand? One is 8, one is 9. Okay, so if that's the case, it's gonna be easy. So we only need to worry about the left subarray. Then we're gonna pick a pivot now for the left subarray. Okay. I'm gonna choose Bruno. Bruno still awake? Bruno.
Yes.
Yes. Turn on your camera. Let's find the second pivot now. Come on.
Yeah.
Yeah. What's your second pivot now?
That'll be 6.
Yeah, good. Okay, so we're gonna iterate through the array, initiate the pointer. So what is our left pointer now? What is our left now?
That'll be 5.
Mm-hmm. Yeah. What is right now?
Wow, there are 2 5s there.
Huh?
There are 2 5s there, right?
Yeah, I don't.
There are 5 5s.
Yeah, yeah,
ಅದು
yeah.
ವೈಸಲ್ಲ
Oh,
ಕಂಪ್ನಿ ವೈಸಾ
yeah, yeah, yeah. So that was like left now is
ಅದೇ
5,
ಪ್ಲೇಸ್
one, right? Left
Yeah.
now, and the
Dito na
right
di.
now is this.
అదే
Uh,
మీరంటే తీసుకొచ్చా నువ్వు నీ షాప్ లో తీసుకొచ్చా
Sonny, can you mute yourself, please?
షాప్ లో ఉండవా
Okay, can I
వీడెక్కువ
actually,
పానీ
actually,
తెచ్చుకోవచ్చు నువ్వు
It's funny. Oh, okay. Okay.
సారీ గైస్
actually, you want to continue?
Yeah, okay. So we have to check again if left number is greater than pivot number.
Yeah. Okay, hold on a second. Let me copy that one. Hold on a second. Ooh. Okay. Okay, so that was wrong one, right? So question to ask is left noun are greater than pivot noun. What is left noun?
5.
What the heck? Okay, that was 5.
Yeah, 5
Oh my
is greater than 6.
What the heck?
What's happening, Jennifer?
I don't know. Okay, I cannot copy paste.
Look what you've done.
It's not that much.
Really bad. Okay, I can copy paste the maybe 2 sentences. Okay, hold on a second. Okay, if that's the case, it's good. Left now what?
5. Greater
Pivot
than
noun.
no.
Right now.
5 less than 6, yes.
Okay, what do we do now?
We have to move the left pointer one step towards the right.
Okay, no, do not swap, right?
Yeah, no swap.
Okay, I'm gonna copy it so I don't need to type anymore. Okay, so we're gonna do that one, and we're gonna do that one. Hopefully it will work. Yay, it works. Do not swap to the left. Okay, so second pivot now round 2. Okay, so what is our, okay, hold on, 6, and that was, okay, hold on a second. We're gonna copy that one.
Yeah.
Okay, so, okay, we're gonna init the pointers. Okay, so what is the pivot now? Actually, you still continue, yeah.
6.
Yeah. Okay, what is the left noun now?
2.
Huh?
2.
Yeah. What is right now?
It's going to be 5.
Yeah. Okay, so what we're gonna do?
We have to check again if left is greater than.
Yes.
pivot.
Okay, so we're gonna ask left noun, yes, 2. Greater than? No. Right now, yes, 5. Greater than? No.
No.
Okay, no, what do we do?
We have to move both the pointers like one step forward and backward.
Okay, hold on a second. Let me take a look. Okay, let me take a look. One is no. Okay, okay, so if it's no, what do we do for
You have to move both left pointer one step, like one step towards the right, and right pointer one step to the left.
Yeah. So no. If it's both no, we move left point to the right and the right point to the left. Okay.
Yeah, that's what I just said.
Okay. I forgot.
Okay.
Yeah. I need to make sure, otherwise you're gonna mess up. Okay. So we're gonna do not swim, move left to the right. Okay, now we're gonna do the wrong three. You can pick somebody, do it.
You can pick someone. I don't know who's still active. Vishesh looks active.
Cecilia, are you still awake?
Sorry, I lost track. I was distracted. So where are we again?
Okay, if you distracted, change another person.
Okay, I'll pick Ray.
Can you do it, Cecilia?
I'll pick Ray.
Ray distracted too. Okay, Cecilia, you do it. You.
Okay.
Edwin help you, okay? If you stuck, Edwin help you. What is the period num now?
Pivot num is 6.
Yeah, left to now. We
So
already move pointer, okay?
Yep. Okay. Left pointer is, where are we? 3.
Yeah.
Okay.
What is the right pointer?
Right pointer is 5.
No. We move right point to the left.
Already move it. Okay. So 3.
Yeah. Okay. So what are we gonna do now? Okay, now it's overlapping again. Damn. So that was left. Okay, pivot now is here. Left pointer here. Right pointer here.
Yeah.
Okay. So what are we gonna do? Okay, so we don't do this. We still do the comparison, right? Comparison. Do the comparison. Okay, so left num is 3, right? Greater than 6? No.
No.
Right 3 greater than 6? No.
No, it's less than.
Or is smaller.
Yeah. It's less than.
3 is smaller.
Yeah.
Okay. So when no and yes, what do we do?
We do not swap.
Yeah, then we move left point to the right, right?
Okay, yeah.
Okay, let me make sure. No and a yes. Okay, no and
Yeah.
a yes. Okay, no and a yes. We don't swap and move point to the right by 1. Okay, so here is so now we got the situation, yes. The right pointer is 3. Left pointer is 5, right? So it's like the out of scope. So we're gonna find our perfect position for the pivot for round 4. Okay. Do you know the perfect position for the pivot number?
So the pivot would be on the right right pointer, I guess. Is it?
6 to
Okay.
7.
Okay. Ash, you need a help decision or you just good?
I'm not really sure. Like the pivot should come beside the right pointer. So, but the right pointer is at 3.
Right now, left pointer is what?
Left pointer is 3.
5.
5.
She move round 3. She move from left pointer 3 to right, and the right pointer is 3. So in the round 3 I draw, right? It's like a left pointer here, right pointer here, overlaps. But because the condition question we ask it's not met, then we move the left point to the right. So the left pointer becomes 5 and the right pointer becomes 3. So it's not qualified.
5 is
Okay.
Okay, so when it's not qualified and out of scope, that is exciting moment. We can swap and find the perfect position of the pivot number, right? So
Yeah.
okay,
Yes,
so it's
so
moment.
swap
How we
pivot
gonna
with the
swap?
left. Yeah,
Yes,
this is itself.
we
We
swap which number to which number?
Pivot.
we swap pivot with the left.
Huh? What?
Pivot and the left.
Okay, so whoever volunteered to answer for him. We swap which number with which?
Can I see?
Yeah.
So we swap. Pivot is now 6 and left is now 5. So we swap
6 and 5.
between 6 and
No,
5.
remember the 5 already out of scope because left pointer should never be on the right of the left pointer. So we swap 6 with right number. Remember for our first pivot non-perfect position?
Yes, I remember.
Yeah, so we swap 6 with right number 3. Does anybody do not understand? Oh, hold on a second. Okay, so Devon, are you still there? Which number should we swap?
Whichever one is appropriate. Okay, what's the question? So, pointer number is 6, our left number is 5, our right number is 3. So, we don't swap anything.
So for like this one, the pivot number is 6, left number is 3, right number is 3. Oh, so do we need a swap here?
You said the left number is 5 and the right number is 3? That's the one I saw, unless we're, because you keep moving around, I don't know what.
Oh, yeah, we need to swap the 5 and the 6. Sorry, guys. Okay, I think we made a mistake. Can you guys help me find where is the mistake?
Left number is 3, right number is 3. No, you
Let's
just
be back
continue.
to this.
So in the previous steps, we need a swap, but we did not swap. Which round we should swap?
I think when
I don't
both
see
are
a
three.
time when we should have swapped yet. Oh my god, this file is huge.
Okay, let's see. So for round 1, right? So we have pivot now is 6. And the left now is 5. Right now is 5. Then we move the left pointer to the right. So our left now is 2 and the right now is 5. Then do we swap here?
No.
No, look. So here is wrong. So 5 smaller than 6, yes. So here we are wrong. So when this one, so we are not move 2 pointers, we only move 1 pointer. We move left pointer by 1. Okay, so our left pointer is 2, move to 3, and 5 don't move. Then we swap. So now our round 3 is pivot num is 6, left num is what? 3, and the right num is 5. Because we don't move 2 pointers, we only move 1 pointer. 1 is no and a yes. You guys understand?
Yeah.
Okay. Then Then when the left num is 3 greater than 6, no, and 5 is smaller than 6, yes, then what we gonna do? Move left point to the right by 1. So our left pointer is 3. We move to the right, which is 5. Right? Then our right pointer still 5. So it's overlapping. Left num is 5, right num is 5. So we are not reached the perfect moment yet, because the perfect moment is when the left pointer to like greater than the right pointer. Okay, so we need to do one of that. Okay, we're gonna do it. Okay. So question is, left num is 5, right?
Mm-hmm.
No, and the right num is 5. That was.
Wait,
Yes.
so you did a swap?
We have not did swap.
Okay, good.
So right now the situation is the pivot num is 6, and the left pointer is round 4. Left pointer is 5, and the right pointer is 5 too. Then because no and yes, so we don't swap, and we move left pointer to the right, so the left pointer become 8, and the right pointer 5. Then the left pointer are out of scope, so we swap 6, 5. Now it's right. We missed a step in the round 3. We missed a step round 3, which is no and yes, but we made a no. Got it?
Got it.
Yeah. Okay, no problem. Thanks for joining. It's just long. Okay, so we're gonna swap. Okay. Okay, so we are round 5. I think Ashley is still with me. You know.
So we're swapping the right
let's
element, right?
swap. Ashley. So
Okay.
tell me, after round 4, what we are?
We have like 5, 5, 2, 3, 6, 8,
Okay,
9.
now 6, right? Left now is what?
Left num would be 5.
No.
Sorry, 8.
Yeah, because we move to the right. And the right num is what?
Right num is 5.
Yes. Okay, so because, okay, I'm gonna write that one. Because, because left pointer are greater than
So outside,
the right pointer. So we're gonna swap the period num with the right num. And then we find the perfect position. Okay, so after we swap, Ashwin, can you tell me?
yeah, it would be 5, 5, 2, 3, 8, 9.
2, 3, what?
6, 8, 9.
Yes. Okay, now it's good. Okay, so now we found the 3 perfect positions, right?
Yeah.
You know, it's not difficult. It's just complicated. So you guys just need some need some patience. Okay. So that perfect position we will not move. We will not move these three numbers. Then we only iterate through these. Okay. Do you guys still wanna kind of like do it, or you guys know and move to the code? Huh? Is anybody still awake?
Yeah, we are awake.
Okay. Okay, so now what we're gonna iterate the so we're gonna iterate this, right? We're gonna iterate this. Then we find the third pivot now. It's the same thing. So I think we can move to the code, right?
Yeah.
Okay. Jasmine, you wanna walk through how the process or no?
Yeah, I would like to.
Okay, so I let you do the process for one more, then we move to the code, okay?
Mm-hmm.
Okay, tell me which is the step one.
First, we will decide the pivot number.
Yeah, we need to find the pivot now, right? Okay, so what is our pivot now?
Let's say 2.
No, pivot now. 5.
5.
So no, okay, you
5.
tell me which array we're gonna iterate. Just
Why is the pivot number is 5 now? I think last pivot number was 6, right? So we are changing this time pivot number.
we already swapped. We swapped and we found the three perfect positions, 6, 8, 9. So we don't need to do this anymore. We only need to iterate through the left array.
Left array.
Yeah, so which is 5, 5, 2, 3.
Mm-hmm.
So we're gonna do the pivot quick sort for 5, 5, 2, 3. Okay, so our pivot number is 5. Then we're gonna iterate through the 5, 2, 3 array. So what is our left point?
So first 5 is our pivot number 9 now, right?
What is our left now?
Left number is 5.
Yes. What is the right now?
3.
Yes. Okay, so what a question to ask?
If the left number is greater than pivot number.
Yeah, left greater than pivot now, right? So left now is 5, greater than pivot now is 5.
It's equals to 5 now. It's equal, right? It's not greater than 5. It's equal to 5.
Oh no. Yeah. Okay. That is no equal. Only ask great and less. Okay. So what's the other question?
Right num is less than pivot number.
Okay. Right now is less than pivot now, right?
Yes.
Okay. So what is right now?
Yes.
3 smaller than 5. So yes. So why is no and yes? What do we do?
Remove the left pointer by 1.
Jocelyn, you say.
Now left num will be 2.
Yes, do not swap, right? Then move left pointer to the right.
Yes.
Okay, so we're gonna Okay, so we're gonna get that one. So what is the pivot now? Left wing.
5.
Yeah, left now?
Now left num is 2.
Yeah. Right now?
Is 3.
Yeah. Left now is 2. Greater than 5? No.
Swap.
Right now 3? Yes. Do
Yes.
not swap
Yes.
left to the right. Okay.
Yes.
Okay, we're gonna do
And the left.
almost done. Okay, so that was round 3, and what is left now?
Now left pointer goes to 3.
Yeah, right now.
Right num is 3.
Yes,
Oh, right num is also
yes, we did not move the right now. So the left now is 3, right? That
left.
was no. Right now is this, yes. Then we move left now to the right. So left now is 3 to the right becomes 6, and the right now is still 3. So we reach to what?
The exciting moment.
Exciting moment. And we're gonna find the fourth perfect position of pivot now, okay? Okay, can you continue? That's the way? Okay, you know how to find the exciting moment, right? Okay, so what is the situation now? Okay, hold on. Okay, so that is like this, right? And since left pointer is greater than right pointer now, so we found the perfect position of third pivot now. Okay, so tell me what is the pivot now? 5? What is left now? Left now.
Left num is 3.
Yeah. No.
No,
We move the left point to the right.
6.
Round 3, the left now is 3. Then we move the left point to the right to reach to round 4. So what will be our left now for round 4?
Left is 3 and right is 6.
No. We are at round 4. Left 3, right 6 is round 3. And right now will never be 6 because remember 6, 8 is perfect position. So we don't move this anymore. We only lock 5, 5, 2, 3. Okay, so round 4, what is left now?
6.
Yeah. Do you understand that, Jaswee?
6 is left number, right?
Yeah. Because round 3 left now is 3. Then we move to the right. Then round 4 left now becomes 6. Right? Yeah. What is right now?
Right num is 3 now.
Yeah, 3. So left now greater than right now. It's not to meet the requirement of the while loop condition, right? So now we're gonna swap. We're gonna swap what? We're gonna swap what number to what number? Perfect position. Swap what?
Swap pivot with
Left num.
3 and 5. Pivot number and right number.
Yes. Thanks. Thanks so much, Jasmine. With the right number, right? Okay, so now we become right number is 3, 5, 2, 5, 6, and 9. Okay, so now we got 5, 6, and 9, and I'm not going to do it anymore because I think everybody understands. So we're just gonna loop through 3, 5, 2, and the same procedure just like Jesslyn walks through. Okay, so here we found our third pivot now, which is 5, 5, 6, 8. Yes, our, like the third pivot now. Okay. I'm not going to do it anymore. Okay, so we only loop through 3, 5, 2. Okay, and we just do another pivot 3, then we compare left to right, then swap, then become 2, 3, 5. Then it's output. Okay, we can move to the code now. Devon, are you still awake? We're gonna do the code. Devon.
Mm-hmm.
Yeah, you need, can we please do the code now?
You got tired?
Yes, we can hear you, David.
Oh man, my no, don't
I
crash.
don't understand why everybody tired. I am the one keep on talking for those to swap, and I'm the one should be tired, and you guys just resting.
You are right,
The
David.
one eye napping, one eye looking, pretend. And you guys tell me you're tired.
No, no one. First of all, we could all be tired. It's not a competition. Okay.
Okay. Okay, let's do it.
No.
Does anybody need a 2 minutes resting or something like that? Or not resting, 5 minutes waking up.
5 minutes waking up. I've been
It's not resting, it's waking up.
I've been here for support.
Ray, how many minutes do you need for wake up?
You're just disrupting Ray's entire sleep schedule.
I'm all right. I don't know.
How are you doing, Ray?
I have my own solution. You guys did a very complex implementation.
I mean, they're all complex.
Later.
No, it's not that. I have a different solution, which is much easier to understand. But I mean, I haven't seen your solution yet, but I know what you're about to do.
Yeah, but me just walk through, find the perfect position of, the algorithm. I think that is the step for all solutions, same step.
Not really. You'll see mine, but go ahead with yours.
Okay, Devon, you first, and then Ray second.
Yay! Hooray! Okay.
I'm gonna put your name first, Ray. So.
My name where?
Devon, your solution is my logic, correct?
I mean, I assume so. Most likely.
Okay. Let's do it. Are you gonna type it?
Yeah. Okay. No, I'd rather not. Just because I'm working from a whole iPad here, so. But okay.
Funny, do you have other solutions? Funny and Bishi?
Same thing. I used to just use the start and end pointers. I've done the coding, but I don't know whether it's
Okay,
gonna run up.
okay, you guys keep it later, okay? Okay, then let's do it so they can do their solution too. Let's do it. Okay, thanks, Bishi.
Don't rush me, I'm low energy. So just create the helper function first, because that's where literally everything is going.
Do I need to create outside or inside?
Outside, it doesn't matter. No, outside.
Output function, what's the name?
Did you see the solution? I don't want to come up with names, because then you complain about
I
the name.
don't have time to see solution. I was busy with,
With not drawing a graph. No, just name it helper. I don't know. QuickSort helper. I don't have.
Okay, I can see solution. Oh, you mean swap?
No, the helper. Okay.
Help function, what's the name?
Literally, just name it QuickSort helper. Just name it a helper.
Name it Devin's helper or something.
Something. Just don't question me about these small minutia things. Just name it helper.
Okay, what was that function for?
For I don't know. It's just makes the we don't know. It just makes it easier to keep track of where we are in the recursion, because this way uses a lot of recursion, and it's easier to see that logic in a separate function than.
Okay, help function called help.
Yes, just name it helper. It just takes an array, a start position, and an end position.
So what do I write? I and the J?
I said an array, a start, and an end position. So array, I and J is not descriptive. We will lose track of what those are very quickly.
Okay, just tell me what's the variable name.
Array, start, and end.
So start and end is index?
It's where start and end act as our arrays. As we go through the loop, as we go through each iteration, you mentioned that there's a partition that's already sorted and a partition that's not sorted.
Oh, so the start is the sub-array.
Start is the start of the array, end is the end of the array, and as we keep going, our left and right pointers will keep track of what's sorted and not sorted based on the start and end positions.
Okay. Do you guys understand? Can I ask a question? So, for example, if our period noun is 9, start means sub-array 852, and end means sub-array 563?
We've written 3 lines of code. Now is not the time for questions. No, start and end is literally going to be the start and end of the array. And as we call this function recursively, we will change. Start and end will change based on which part of the array we're looping over.
So start is the left pointer and end is right pointer?
They're not pointers. It's a way to partition the array. So go to your notes. Go to just the last thing, wherever we stopped at. Wherever you got tired and said, let's do the code.
I don't understand.
I'm trying to tell you, go to the bottom of your notes.
Okay.
Okay, so you see how the left side of the array 3525. Well, 352 is basically unsorted, right?
Yes.
And 5689 is in order, correct?
Yes.
Basically, each time we call a recursion, the right side is going to be the end. As far as going to dictate what our end is, and just that we loop through and we make sure that it's sorted correctly. And our start is going to be a pointer to help us figure out where we again, as we call this function recursively, our arrays will get smaller and our start and end will get smaller. So our end in a recursive function at this point would be 2, and our start in the recursive function would be 3, and then we would call our helper function again to sort those numbers.
Okay, got it. Okay, continue.
Okay. So, first thing we want to do is check if, because start and end are just indexes, alright? So, if first thing we want to do is, since we're using recursion here, we want to set our base case. And we want to check if start is greater than end.
Okay, so hold on a second. My monitor is a little bit not good. Hold on a second.
No, you don't wait for me when my stuff's messing up. I gotta pee.
Okay, hold on. Give me 2 seconds. My monitor is not good. Okay, good now. Good. Okay, where is Devil now?
I'm here. What do you mean?
Okay, let's continue. What do you want me to do?
If start is greater than or equal to end, return.
Start is greater equal than end?
Well, if start is greater than or equal to end.
Okay.
Return.
Return what?
Return nothing. I said this function is a recursive function. And so, as such, this is our base case.
Yeah. Okay. What's next?
Okay. So we're going to create our variables. We're going to create our pivot variable, our left variable, and our left pointer and our right pointer.
Okay. So left pointer and the right pointer, right? So do I need a let or count?
You forgot the pivot. Let, because we'll be changing them.
Okay. I don't want to do fancy one. I just do the loser one. Okay. Pivot pointer too, or pivot now?
Pivot's not a pointer. It kind of stays the same the whole time. So.
Okay, so pivot now. Okay, what is the pivot?
Our pivot's going to be our starting number. We're just going to go from the front. The left pointer is going to be the number after that.
Plus 1, like this?
Yes.
Okay, what is the right pointer?
Our pointer is going to be our end number.
Okay. Is it correct?
Is correct.
Okay. What's next? Loop?
You said loop?
No, what's next?
Oh, I thought you were answering. It's a while loop.
Okay. Can you speak a little bit louder? I couldn't hear you.
No! I cannot speak any louder.
Okay, so while left pointer is smaller equal than right pointer, right?
Yes.
Pointer. Then what we do? Swap? No. What we do then?
First thing we need, well, here's where we write all of our conditions to determine whether or not we swap. So the first thing we want to check is, first thing we want to check is, can we swap the numbers we have right now? That's the first thing we check.
Okay.
And to do that, we need to check if the value of array at index left pointer is greater than the value at array pivot.
Greater, right? Yeah, that is what we do.
Array pivot.
Array?
The pivot number is we just have indexes right now, so we need the value.
Okay, so that's called a pivot pointer then.
Yeah. I guess it could be the.
Okay.
No, it's fine.
Okay, good.
And.
Oh, and. And what?
And the value of our right pointer is less than the value of our pivot pointer.
Okay, that's right.
Right pointer.
Oh, yeah. Sorry. Right, pivot pointer. Good. So anybody sleeping, that is the yes-no situation, okay?
So, if that's the case, then we swap.
Okay, if both conditions need to swap.
Sometimes the code comments itself. But yes.
Okay, swap what?
We've written 1,000 swap functions at this point. They all work the same way.
Oh, do we need to create a swap outside?
Yes.
Okay, yours is already help function. Okay, I can get a swap here. Sitting swap right here. Okay, good.
Yes.
Okay, then we put what?
The indexes we want to swap, which are left pointer and right pointer.
So we swap left pointer, right pointer, and the array.
Correct.
Right? Okay. Okay, good. What's next? I guess it will be next if they right?
So.
Huh?
Oh.
Hello?
I think he was talking to someone else. So.
What did you say, Evan?
What did I say?
Yeah.
So next next we just are my mic settings on there? Wow. Okay. Google's weird. But next we just check if so whether or not that's true, we check if our left pointer, it doesn't matter which order, but we check if our left pointer is less than our pivot. Or less than or equal to, sorry. Less than or equal to.
Still it, right?
Yes.
Okay.
And if it is... No, that's it. This.
Okay.
And if it is, then we move our pointer over. We move our pointer 1. Pointer
Okay.
plus plus.
Move left point to the right, right?
Yes.
So that will be left pointer plus plus, right?
Yes.
Mm-hmm.
And then we just kind of do the same with the right pointer. Kind of.
Okay, can you just tell me?
If array right pointer is greater than or equal to pivot pointer, then we minus.
And we right pointer minus. Okay. Then where are we gonna call this help function?
We're going to call it in our main function, of course.
We don't have a main function.
The QuickSort function is our main function.
Okay. So we done with this help function?
No.
Okay. Please continue.
Continue where? You're jumping all over the place.
No, like a while loop. Is the while loop done?
The while loop is done.
Okay. Okay, while loop done, do we need to return something?
Eventually.
Okay, so does the help function done?
No.
Okay.
So continue with the helper function?
Yeah.
Okay. So, based on the explanation Jen was giving earlier, this loop continues up until the left pointer crosses the right pointer. And once the left pointer crosses the right pointer, now it is time to swap our pivot value with our right pointer.
Yes. So we're gonna put that one in the while loop or outside the while loop?
Outside the while loop. We only run it after the loop is done.
Okay, swap the pivot value with the right now. Okay, so we just swap, right?
Yes, and we swap our pivot. The indexes will be the pivot, the pointer, and the right pointer.
Okay, and do I need the array too?
Yes, you always need the array.
Okay, cool. Good. Then we're done, right?
Nope.
Oh, then what's next?
The most complicated set of steps in the history of mankind. So,
We call the helper function again.
Oh, so we're gonna pick the second pivot now.
basically, yes. And we gotta determine which part of wait, no, our pivot number. Okay, no, you're making me think too far ahead. So, now that we've got a portion of our array sorted, now we're basically going to determine. I don't even know why this part is even here.
determine what?
Just of course, it still works, but we'll follow their solution anyway. So, actually, no, we won't. I don't feel like explaining all this right now. So, we're now going to sort. We're basically going to call our QuickSort again, and we're going to recursively call our helper function rather. We're going to call our helper function again, and we're going to basically call it on the different parts of the array.
So we're gonna call the help function in the main function, or we're gonna do something after swap.
Our helper function is going to recursively call itself, and our QuickSort function is going to be the initial call of our helper function. Don't look at me.
So that's the next term.
We could technically do all this quicker. I don't feel like explaining all these conditions. So basically,
Can I have a stupid question? Stupid but straightforward. So you tell me write the swap for pivot number and the right number inside the help function. Then do I need to write anything after swap function inside the help function?
wait, can you repeat that?
Are you looking at my screen? I am on line 81.
I see your screen. I didn't hear what in the world you asked.
I call swap help function, swap the pivot num with the right num. Then do I need to do anything after that inside the helper function?
Yes, I said we're calling our helper function recursively. So we're going to call our helper function again at the bottom of the
swap. Okay, this needs memory because he picked this hard question. Then he sleeps, you know.
I don't do hard questions. I do not feel like trying to explain this vocally. So
then he sleeps.
okay. Wait, none of that. Change that to your variables. I did not feel like trying to explain what all of this does without anyone seeing it. So that's.
You asked me to change?
I'll change it. You just.
Okay, so count the left subarray is smaller. Okay, so we need to change our help function called the QuickSort helper.
You don't have to, but yeah, I could just name it helper.
Okay, because it's easier. Okay, I don't understand the line 85.
I know you don't. That's why I didn't want to vocally tell you it. So, it would have been even worse. Line 85, because the way this explanation is given, and the way QuickSort works, every time we go through the sort, we have kind of two arrays, one that's sorted and one that isn't. Well, it could be done a bunch of different ways, but basically the way we did it, because we picked the first number, and the way that we swap, the end of the array is always going to be sorted. But in the different implementations of QuickSort, and depending on where your pivot is, it may not always be sorted. So, but typically with QuickSort, you just break your array down, and then you kind of compare the numbers, and then at the end you put them all together, and then you have your answer. So now that we have our right side sorted and our left side unsorted, we basically, line 85 determines which array section is smaller. and based on whichever array is smaller, we loop through that one first, and because that one is already sorted, our checking that one will always be O of n time, and then we just focus on the left side of the array and keep sorting that until everything is in order. And so basically, as our right side of the array in the beginning, our right side of the array would be sorted, and so it would be smaller, and so we loop through that one O of n time, and then we sort the left one. As the right side of the array becomes more sorted and our left side of the array becomes smaller, we then switch to searching the left side of the array first and sorting those numbers until our entire array is sorted, and then we return.
Yeah, so I understand. So that is, for example, like this question. So the left side is 3525. So
Actually,
so
I think that would be 352. I think the 5 would have been already after we switched our pivot.
no, I just say example.
Oh,
That
as an
is
example, yes.
not sorted yet, but we have sorted the part 6, 8, 9, which is find the perfect positions. So we're gonna call this left subarray is smaller because the unsorted one always be smaller and on the left of the sorted one, right? Then we're gonna kind of like start the pointer right pointer -1, which is
Right pointer would be, so
yes,
if
right
it's
point
right
-1
pointer
will,
would be 5.
yeah.
Well, no, if we already did the pivot, if it's 6, 8, 9, our right pointer would be 6 currently, I believe. So it's -1.
I think because when we do that one, then it's kind of like we have like the left pointer is greater than the right pointer. So we're gonna minus
So
that
once the
one.
left pointer is greater than the right pointer, we switch the values of the right pointer and the pivot, but we don't actually change the right pointer yet. So the right pointer
Yes,
would still be 6. So that's why it's right -1, because we're assuming everything to the right of right -1. That sounds so confusing, but we move our pointer +1 because everything to the right of that index is sorted already.
yeah, sort of like that. So I don't
It is like
understand. Okay, 7 is yes. So we call that function.
it's
So
just a conditional.
condition. Okay. So this is condition. You just put a condition in a variable, right?
Yes.
So
So basically, the result of this is going to be either true or false. All that it checks if the left part of our little subarray is smaller or not, and based on that equation, it calculates the length of basically the start and end positions of each side, and it calculates whether it's smaller or not, and based on that, it decides which part of the array to search first. It's a very small optimization. You can technically you can get rid of it and just have and search either side in any order, and it will still be correct. But it is a small optimization just because one of the smaller side will usually it's just going to be quicker. I forget the exact explanation, but it's quicker to go through the sorted side first.
yeah. Okay, I can let you like set you free, so we can call that one in the main function now.
Well, you just got to call the helper function and pass in the parameters.
So how we gonna call here?
Well, what do you think our initial array start and end should be? We're following our helper function. We need to start, and
Array?
it takes 3 parameters, or the array. The array is constant, and we need to put a start and an end. Just I don't know how that got there. Don't do that.
So,
And then our
so
start
the
position.
array will be the input array, right?
Yes. It will reference that array the entire time.
Okay. So what is that?
What is the typical start of our array? No, we need to pass in actual values.
Array at index 0.
Yes, but our start is an index, so we would just pass in 0. Our start and end are going to be indexes, or indices, rather.
Yeah. And will be length minus 1, right?
Yes.
Array dot length minus 1.
I just assumed you said array dot length, but yes.
Is it right?
Well, and you return the array, of course, but yes.
Then return array?
Yes.
Okay. Okay, should I run it?
We need to rename variables on swap function. We should not, because the variables, those are just parameters. Those are references to whatever we actually pass in. They don't have, I and J don't actually have to say start and end.
Yes, I can explain that one too. So that swap function always ID, and it will always work for any sorting function. Just put that one outside.
Yes.
Okay.
All those parameters are just references to the actual data we pass in. It just so happens that we name our array throughout the entire thing.
I am hungry. I haven't had dinner yet.
I want dessert because I ended.
What dessert do you have?
Don't worry about it. You're hungry. You should eat food, not dessert.
Okay, I'm gonna put that one here. Oh. Okay, please pass. Yeah, yes, pass. Yes, anybody still awake? We pass.
Hopefully Ray is, because I want to see the other solution.
Okay, so we're gonna, Devin, can you explain the time and the space complexity for this one very quick, so we can take a nap and other people can do the solution too?
Time is
Talk about time very quick.
average case, which is what I care about right now. And so our average is going to be n log n. Because because it's sorting. But we have to loop the array at least once to sort it. And the amount of elements we sort, or the amount of elements we loop through in each iteration gets smaller and smaller, basically.
Can you type it?
No.
Why? You are in. Can you please type it? I couldn't catch your speaking speed.
I don't think.
Okay, say it one more time. Oh yeah, thanks so much. Please.
No.
Why?
Because I'm mean like that.
Huh? What did you say?
Because I'm mean like that.
You're very nice. Thanks so much. You type, I read.
No. Just move on to the next thing.
Just your time complexity in the right here.
How I speak and how I read are two different ways. Just
You just type it. Thanks so much.
just move on to the space.
This I don't know.
No, it would be.
We need to go through every element of the array.
Also,
Then gonna shrink the array using while loop. That's why n log n, right?
for time complexity,
Yeah. Loop through. Okay, we need to loop through the array at least once to make sure it's sorted. But the amount of numbers we check at each pass gets shorter and shorter. Yeah,
don't do
remember we find the perfect position 1, perfect position of pivot num second, perfect position. So we find the one after one, then the unsorted array becomes shorter and shorter. Is that what you mean, Devon?
Yes. The more we find the array in perfect position, the less we have to actually search and sort through.
Yes, I think it's very good.
Unless, of course, the array is backwards, in which case everything fails and it's O(n) squared, but you don't have to write that down.
Yeah, very good explanation, Devon. Can you please tell us the space complexity?
Except that the big O always takes care of worst case, considers worst case.
Yeah. But
That's
if that
the goal.
was the case, everything would be O(n) squared, I feel.
Yep.
Well, not everything. Yeah.
I don't know. I think there's. I have to look at merge sort. I think merge sort and sweep sort.
Hiya, why everybody so get some energy, Jesus.
Space complexity is log n.
That is worst case.
Yes.
But I don't know why it's N2.
Because everything is already sorted, you have to go through every single possible loop to sort everything.
Can I ask a question? Why everybody so low energy is because the QuickSort too difficult? Oh my god, Bruno, you know how to type Chinese? That is what exactly I said. Yeah, that is Chinese. Gee,
Hey,
Jesus.
I live in China.
Ah, you live in China now?
Yes.
Right now?
Yes.
Wow.
Sure.
City.
Nice.
Wow.
Yeah.
Which
Mandarin and what else do you speak?
Huh?
Xiamen City.
Really? Right
Yes,
now?
really. Yes.
Wow, that's
Xiamen.
I know Xiamen, it's very hot.
Yeah. What's your city?
So right now you are in Chinese time?
All right. Yes.
Wow, cool.
Xiamen.
Can you talk space complexity then?
In Chinese or in Mandarin or in
So what are you doing in China? Teaching English?
No, well, like basically, I came here for study, and then I'm living here. Yeah,
You came to China study?
yeah, and
Study
right
what?
now, right now, I'm just living here.
Oh, what do you study in China? Chinese or English? Don't tell me you go China
Chinese,
English.
Mandarin, yeah,
You study English in China
Mandarin.
or Mandarin Chinese? Yeah. Cause look, my English is so bad because when I study English in China, all the English teachers are Chinese. That's why
Uh,
my English doesn't speak like really
没
good.
关系，没关系，没关系。
You can literally just speak Chinese.
Yeah, it is. I do.
I'm from Shanghai.
Oh, Shanghai, really?
Yeah,
Wow, good,
yeah.
good.
Devon, can you complete space complexity, please?
No.
Are you excited we have Chinese foreigner?
I mean, no, but way to represent, my guy. Diverse out here.
Devon,
Are you asking me what now?
have you ever been to China?
I haven't. I've barely been out. I haven't even been out the U.S. No.
Have you ever been to like an Asian country, Japan or Korea?
You must be asking somebody else because not leaving America would qualify as not going to Japan or. No, does Chinatown count? We got a Koreatown. We got a Chinatown. Do those
In the
count?
country? Yeah.
I've been to Chinatown. Yeah, it's as good as going to China.
I've been to Shanghai.
Really?
Yep.
Wow, good.
Cool. What do you like?
The silk.
What do you think?
I just remember my wife bought some nice crocodile purse at much cheaper price than going to the name brand stores and buying. We bought a silk bedding for a much better price than we would ever get.
Knock the off.
Huh?
Knock the out one, the fake one.
No, not fake. Definitely not fake for sure. And then I just remember going to the clubs at
We
night
have
time.
clubs, like modern clubs.
Yeah, it's modern.
Yeah. Thanks, Devon. Have you been to the Bounce Rate and the Oriental Pearl Tower?
No, not that I remember.
Okay. How many days have you spent in Shanghai?
I don't remember. It wasn't that many. I was traveling all around. I did went through 4 countries over 2+ weeks in Thailand, Bangkok, Singapore, Hong Kong, and I guess Shanghai. Yeah.
Yeah.
Ray, did you visit the China Wall, the wall that separates?
No, I didn't have time to go there. Yeah, I didn't spend that much time in China.
That's the first place I think we see. If anyone go to China.
Well, I wanted to go to Beijing.
Yeah, Beijing has the Great Wall.
Yeah, and also the Olympic Stadium.
Yeah.
Yes, Devin, this is true. The number of stack frames will be less than the number of items in the array. So the thing that O(n) square, O(n), O(1), oh God, so this doesn't go in my brain. Just I understand O(n).
Okay, Devon, can you please explain a little bit what you just typed?
Isn't that what the typing was for?
Okay, my Chinese friend. See you next time. Bruno Chinese.
Say bye in Chinese to him.
Hey?
What?
Jennifer, say bye in Chinese, in Mandarin.
再见, Bruno.
再见，拜拜，再见。再见，wow.
I'm just
Yeah.
gonna log off and watch anime, but that's not Chinese either, so it doesn't even matter.
Okay, that.
Anime is Japanese, right? It's not Chinese.
Yep, and I'm gonna watch it dubbed, so it's not even gonna be Japanese either. It's gonna be English.
Japanese 课的三样那拉，再见。Okay, Devon, please explain this in English then.
What did I write? In Mandarin? Okay. When we go through a sort, we sort our numbers, and then we call our function recursively. Every time we call our function recursively, our array becomes more and more partially sorted, so we do not run the same number of compute for the number of stack frames before we reach our base case and travel back up. The space we use is less than n, which is the length of our array. In relation to n, the length of our array, the number of recursive calls is less than n. And we never go that far deep. So.
Okay, sounds pretty good. Okay, solution 2. Ray.
Alright, I'm gonna show you a YouTube video of a guy that shows a deck of cards to explain the quicksort.
Okay,
the way I implement it. So
share your screen. I stopped when you share your screen.
yeah, I don't know if the volume's gonna.
I like videos. So let's do it.
So I can half napping, like one eye napping, one eye pretending listening. Okay, please share your screen, right? And you have been to my hometown too, so share your screen. Three minutes? Okay, cool.
Oh, do you see it?
Yeah.
Yeah, I see it.
Okay. All right.
You don't do anything.
Yeah, no sound. Okay,
Sound
you
is
make
low.
sound a little louder. I'm gonna change my background.
Yeah,
Wow.
I don't know how to turn the audio on internally from sharing. Where do what is that a setting to share audio?
I thought it was sharing. It just sounded really low. Can you play it again?
Yeah, you have sound.
Default internal speakers. Let me use.
Turn your internal
default.
speakers up.
Yeah, it's on my internal speakers. Okay, I mean.
And the volume's all the way up.
Use different devices as your mic and speaker can cause echo. Whatever. Let's see.
Don't believe them.
Yeah.
Okay, so again we start with unsorted list. This time we partition the list into 2 bits. So rather than just split it into 2 bits equal size, we take one element, which we call a pivot. It doesn't really matter which one you pick. I mean, actually it does matter a little bit, which I'll get into in a minute. Okay, so we pick one called a pivot. We'll just take the rightmost one. Okay, so we've got 5. We put that there. So every element in this list that is less than or equal to 5 goes on this side, and every element that's greater than it goes on this side. So 7 goes on the right, 8 goes on the right, 7 goes on the right, 4 goes on the left, 3 goes on the left, 10 goes on the right. So then we do the same again for these 2 sublists we've got. So we take 3 as the pivot for this one, and 4 is greater than it, so it goes on the right. So with this one, we take 10 as the pivot, so everything less goes on the left, so it's actually all the elements. And then we keep breaking these down so we've got either one element or no elements in each list, so we know they're sorted. Okay, so we take 7 as the pivot, 8 goes on the right, and 7 less than or equal goes on the left. So then we join all these lists back together. So we start at the bottom, we take the pivot, everything on the left goes behind it, everything on the right goes on top of it. Okay, so we've got the pivot here, put 4 on top of it. We've got 10 here, everything on the left goes behind it. And then here we've got the pivot, so these go on its left, and these go on its right. Okay, so now we've got one sorted list. Now, you do have to be careful about what you choose as the pivot. Usually what you'll do is you'll either pick the first element or the last element because it's just easier. Ideally, you want to be able to split the list into about 2 even parts, so really you want the pivot to be the middlemost number, but you don't know what that is at the start. So in the average case, it's the same as merge sort. We've got n times log n, and in the best case, it's still n log n. But in the worst case, well, let me show you. Okay, so let's say we've got a list that's already sorted. So I'll just take the cards we had before. If we always choose the pivot from the rightmost element, we've got 10. So 10 is the pivot, so all the elements left on it go on the left. So we've got all the elements, basically. Okay, so then we pick 8 as the next pivot, all the elements go on this left. When you pick 7 as the next, then all the rest go on the left. We pick the next 7, and what you see is we end up with cards all the way down here. And then we've got to merge them back together. Okay, and actually, that works out, in the worst case, as n squared. So again, it's the square of the input size. So we've got the worst case of bubble sort is still n squared. And the worst case of merge sort is still n log n. The highest card will definitely have been swapped all the way to the end. So actually, you don't need to check that one anymore. You can move that off.
Okay.
These dodge part.
All right. So you got that right?
Yeah. No,
Yeah, that's how I was originally explaining it.
I walk through.
Yeah. So that's the way I pretty much implemented it, and I did it recursively. So the base case is when your cards are less than or equal to 1, right? You just return that array. So we set the pivot is equal to the last number, like he did. The very last number is the length minus 1. You start with your left array and a right array, right? So I'm putting everything in one side, left and right of the pivot. So less than or equal to, I use a for of. So each element or each card of the array, and the difference here is you take from the 0, you're breaking a sub problem, right? One less. You don't want the pivot. You know the pivot's the last one, so you want to take every element or every card from 0 to up until before the last one, because your last one's always a pivot. So every card of there up until the very last one, because that's your pivot. So if it's less than your pivot, put it in your left array, push it into your left. If it's greater than, push it into your right. So that's that. And then recursively, what you want to do is when you see it, you break it down, like it may have 3 or 2. You eventually want to break it down so you only have 1 card in each left array or right array, right? The way he did it. So you do a spread operator of the quicksort, because you're packing this inside an array. So quicksort of the left array, and then you surround it. The pivot is right in the middle, exactly in the middle. And then everything that's greater than just goes to the right. You unpack it, and that's it. And I've tried it with a bunch of test results. And I mean, I can walk through like quickly a small sample size, demonstrate it. And so here, the order is going to come out to eventually 5, 22, 41. So the pivot is going to be starting on the right. Anything less than 22 is going to go to the left array. So this should go to the left array. Everything greater than 22 will go to the right array. And then it will recursively call in here. It'll say, hey, it'll hit your base case quickly. Less than or equal to 1, it was just going to return it. But in the end, it's going to say, hey, give me everything to the left, which is going to be 5, is going to be in your left array. And then right in your middle is your pivot, which we know the pivot is the last card, was 22. And that's just going to append anything in the right array. And we know it should be 41. So I'll walk it through. Here, whatever. That's just the array. I'm about to call. And I'm inside. Are you less than or equal to 1? No. I'm going to come into, I'll create these variables. All right. So there's 22. There's my empty array. It's going to give you an empty array. Empty array. Now I'm inside my for loop. I'm going to go through every card in here up until basically to here, because we know this 22 is assigned the pivot.
Well, your space complexity will be a little bit worse than 7th because you create extra empty array.
Yeah, let me think about that. It'll be O of n potentially plus O of n, which is just O of n. O of 2n is the same thing as O of n. It gets them out to O of n as worst case, but that's the same with your other solution too. Your worst case is going to be O of n. If everything is sorted, you're going to use exactly O of n space.
The Algo expert, which Devon solution is space complexity is n log n.
That's your average case. I don't think that's your best. Your worst case.
That's not your worst case, no.
Worst case.
Is it? Okay.
But continue explain yours. Yours are very neat.
Yeah. So here I'm already going to hit my base case because my left array is 1. So it's just going to return this 5. See, it's already returned value 5. You can see it. So 5 is going to get stored, and now it's going to go and it already picked up the pivot. It's already there. You don't see it, but it's already stored 5 and this pivot 22. And now it's going to say, hey, my right array, it's only one element. It's going to return everything here, 5, 22, 41. Yeah, returned it right there, 41. And returns everything at once. So now it's going to pop it up, console log. That's it. I mean, I can do the same thing with this. I mean, I'll just do it really quickly.
Pretty good. You're gonna copy paste your solution to our text editor.
Yeah, sure. So
recently you got so many different solutions.
Yeah. Right. I had solutions for the other ones too, but I just never posted them. So here, like your pivot here is 30. So everything less than 30, it's going to be 8, 5. 8 and 5 should be, and 22 will be here. So yeah, 22, 8 and 5 will be in your left. The right array will have 41, 175.
Yeah.
Yeah. So then it's gonna, it's gonna break these down. 22, 8. It's gonna say this is my left pivot. I mean my pivot, and then it's gonna put the 8 to the right, 22
to the right.
To the right also. Same thing here. 75. 100 will go to the right. 41. So it gets down to the 1, and then whatever. It's gonna put them all back together because it's gonna join them via the left side and the pivot and the right side eventually.
Yeah, because this is more of what I was originally taught. Because the Algo Expert solution, I was like, bro, I have never seen that.
That's what I saw you guys talking about. I'm like, what the hell are you guys talking about?
Because the way I was explained is like, the QuickSort is almost the opposite of insertion sort. Like insertion sort, you break everything down, you compare, you put it together. Whereas QuickSort is you compare. Then you break it down and then you put it back together. So it's just like the order of like when you start comparing everything is different. Other than that, they should be the same.
Mm-hmm.
Yeah,
okay.
Divide and conquer.
What is divide conquer?
I started to get my Algo Expert terms up, my algorithm terminology. I don't speak algorithm.
What is divide and conquer?
Divide means you're literally splitting up. I'm dividing. My pivot point is my division, right? Where I'm dividing it into a smaller subset, and I'm picking. So that's like divide and conquer, I think.
So your solution is divide conquer, or Algo Expert solution is divide and conquer?
Yeah, I mean they're pretty much similar. I think. I don't know. I have to look at your code again. I wasn't really following too closely.
I mean, we don't necessarily divide, but we divide in place because we use pointers. We barely even divide because we use pointers for everything, so the array kind of stays the same. We just compare different parts of the array recursively rather than actually kind of separating everything and then joining it together. It's like a symbolic divide and conquer. I don't know. It's a new solution to me. It took me time to like understand what they were talking about, and I was like, I don't have time to look up the solution I'm thinking of.
Okay, thanks, Ray, for your solution. Okay, are you gonna stop sharing and I'm gonna paste your solution in the hour? Can I run your solution? Are you?
Yeah, go ahead, run it.
It probably works as long as you name the function right.
Yeah.
Okay, I am hungry, but that's fine. Okay, so hold on a second. Is Fanny still there?
Saddam?
Fanny.
Yeah.
Oh, Fanny.
You have a solution?
Yeah, I tried. I don't know whether it's gonna work or not. Just to execute it. If it works, I think it's same as almost same as Devin's.
Oh. Okay, I try race. Yay! I'll pass the race.
Cool.
Yeah.
Your solution.
So
Yeah.
Ray's he just picks a pointer and then splits everything.
Big O, your big O.
They go n squared. N squared. I mean n squared, yeah. Just like I explained
Worst case
before.
is always n squared.
Yeah.
So when we big O only do the worst case, right?
Yes, that's what big O means.
Okay. So I'm gonna put on square. What is your space?
I guess O of n. Worst case.
Okay.
Yeah.
Okay, so I would say our CPS log on. Okay, cool. Sunny, you have anything to add, or you good?
Actually, I couldn't paste my solution in the chat box. Like it's like too much. So I think where can I do that?
You can have Stack Overflow. Put in Slack.
Put in Slack.
I wanna put in.
The AlgoBus.
Hold on, I'll divide it into parts. Hold on.
Put it in the DM.
Oh yeah.
You have Funny has access. No, Funny. You look. You still in our VS Code live share. You just paste.
No, I could not. It's read only. I couldn't paste.
Okay. Paste in the Google Meet. That okay. So you have like that many. What is passing?
Passion? What?
Partition. It's a partition, really.
What is
It's a divider.
Partition, yeah.
It's a divider.
Okay, so I paste that one then? Yes, it's from partition to console.log, right?
Yeah, console.log we can remove, I think. Yeah. You can remove the array too.
Okay, so yours is not like can you change to QuickSort? I'm gonna share my screen.
Can you change? Where is this even submitted?
Jennifer, can you share your screen? I don't know what you're doing.
Yeah, I'm sharing my screen.
So you guys understood the solution I showed based on the YouTube, right?
Yeah.
Yeah.
Okay.
Yeah.
It's
Can you
more.
can you post that the YouTube video link?
Sure.
Ray?
Oh,
Sure.
Sunny, I gonna Bunny.
Yeah.
How can you change your passing become QuickSort?
No, QuickSort, I'm already calling down QuickSort.
If I copy paste that one, it will work, right?
If you change the name, it's only being called once.
Don't copy this array thing, yeah.
Okay, I'm gonna check. So Funny, you do this, then after that, Ray gonna explain the card. Your solution.
Again, you gotta change the name.
Yeah, change name. Okay, so I think change here, cut, and change to here. Hey, I don't know.
I believe
What?
it's camel case.
Come on.
QuickSort.
Oh, yeah. Okay. I don't know what's wrong. Oh, camel case. It should be right. Oh, I don't know. 7, do you know?
I know you should do a Control F to make sure you changed everything.
I
Or
changed.
Command F.
I changed everything. Oh.
Undefined. That's not good. Something's not defined. Everything's returning undefined, so you're not returning something. Or something's not... Or it's looking for something that doesn't exist and is not returning it.
Can you look at the syntax?
Well, the QuickSort function doesn't return anything. The QuickSort function itself does not return anything. It may sort everything, but it doesn't return anything. It needs to return the sorted array.
You gotta return, yeah.
So maybe return here. Return, right?
Array.
Yeah.
Return array. Oh, pass 2. So you have
That's
something array not fully correct. Efficiency.
Funny.
Funny. Sorry, funny.
So Bishish had the same logic that he was mentioning in the like the one that Ray did. Like Bishish was saying, you divide the array.
You have something not right.
Okay, I'll check it out.
Yeah. You want me show you case? Not what's not right. So I show you 1. So the output 2, 3, 5, 5, blah blah blah. Okay, so your code, your first number, which is pivot, you did not sort. And this one too, you did not sort correctly. And this one, 1, 2, 3, you put 1, 3, 2. And 1, 2, 3, 3, 1, 2. So yours is like it's not
Maybe
correct.
I need to check the logic once again.
Yeah, and yes, like
Actually, I tried using Python tutor.
Not right.
I tried using Python tutor, but in that it is showing is exceeding 1,000 steps, so I couldn't debug it.
Okay, but good trying.
I mean, yeah, fine. You could, if you want, if that's the case, just do an array with 3 elements or 2 elements.
Yeah, like the examples that were failing were like 1, 1, 3, 2, and stuff like that.
Okay.
So.
Okay. I'll try that.
Okay. Okay, so this is no solution, right? So we are good then. So we can.
Bishish had a solution. He had put it in the chat.
No. I was just looking at the document.
Okay, Bishish, well, where is your solution?
Don't be shy
No,
now.
I don't have.
Oh.
I said I don't have.
Okay.
We're disappointed in you. I'm just kidding.
What? What did you say?
Nothing.
Okay, so we're pretty good. I think we're gonna finish today's call. It's really long time, but at least we walked through all the QuickSort steps. Oh, Ray, you wanna explain the class stuff?
What hard stuff?
card stuff,
Like what? I don't get it.
like the YouTube card.
YouTube is
that?
hard?
I mean,
Oh, the
I just
card.
did, didn't
Okay, fine. That
I?
way.
I mean, that was the solution. I followed his pattern. That my code followed his pattern.
It's
Okay.
it's similar to what we did, but just cleaner, better. If we could say.
Yeah, I mean, my pivot was to the right. He picked his pivot to the right. My pivot was to the right. And then I said I pushed everything that's smaller than that number to the left array. Everything less than or equal to the left array, greater than to the right array. And I just recursively broke it down. I sorted, every on the left array and the right array until there was one number left.
I was gonna say, what was your base case? Because that is what I don't remember.
Yeah, less than or equal to 1.
Less than or equal to 1. Yeah. So
yeah.
He just would sort his numbers into left or right arrays. He would recursively call that function and keep sorting things to the left or to the right up until basically all that was left was a single item array. Then he just joined everything back together based on whether they were based on left array, pivot, right array. It just kept joining things together.
Pivot, right. Yeah, left pivot, right. Left pivot, right.
Okay. Sounds good.
That was the solution I was expecting to see.
Yeah.
What?
The key step was just the recursion that you see, and then it put it together. I mean, the recursion line, basically. But I put it in a specific order. Left array, which was recursively broken down to 1. But when it got to 1, you put the left together. Then the middle number was the pivot. And then you joined it with the right array. So, ideally there was 3 numbers. If the left array was empty, then we just take the pivot and the right. If the right array was empty, we just take the left and the pivot. And then it would bring it up the stack and join again with, multiple numbers over and over until you finished.
Yes. Okay.
So Devin's logic would be faster if the problem was to arrange the array descending, correct?
No, that's the slowest. I don't know.
The way it's explained, that solution is only good for that if it's already sorted. It's not, the space isn't as bad, but I would choose that solution. I wouldn't do that solution again.
Tell you, Devin's logic is exactly the problem walkthrough I demoed, and it's the Algo expert solution, which is the space complexity a little bit better.
Yeah, we don't always agree.
Way too complicated than race, so that is like a compare and contrast.
If I was in an interview, I would do race solution.
Yeah, you want to do things that are intuitive. That makes a lot more sense to you in an interview,
Yeah, but I follow exactly Algo expert.
Oh, if you can remember that long term, then that's great.
Oh, I'm not remembering that beyond today. But the exercise of explaining that solution was illuminating. But
okay.
I wouldn't do it again.
I think the problem works through pretty good. Everybody understands it's just 16 rounds.
I mean, they're all going to have a bunch of rounds.
Yeah. I figured it out in the end. Oh, well, not in the end, but after time, I was like looking at it, I'm like, what the hell? And I'm like, okay, so basically if it's less than, what was the logic? Let me think if I can remember this so I can understand this long term. If you had a pivot, you chose as your first one, and anytime the number was greater than that pivot, your left pointer was greater than, and your right pointer was less than, that number is in the wrong spot because you needed to have the left to be the left and the right to be the right. So if it was the opposite, then you knew that wasn't the right place and you had to swap it in the end. That's the way I remember it.
Yeah.
Yeah, because the Algo expert solution has more logic assigned to it as far as, I mean, it works and I could probably remember it now. I wouldn't add the step as far as comparing which array is shorter, looping that first.
Yeah,
like that's extra. That's extra. Right. The test passed without it, so I would leave that out. But
the micro optimization is less intuitive.
Yeah. But as far as most intuitive to least intuitive, that micro optimization is at the end. Without it, I could probably still remember it. But if I had to come up with it from scratch, it would be closer towards I just break everything down and then build it back up. Just recursive everything to a single item array, and then just slam everything back together.
Yep.
And insertion sort, that's how I remember it too, because that's how I would do that. So I would just take everything down and be like, okay, yeah, you can go here, and you can go there, and compare everything back up.
So next time, Devin, can you use a microphone? I can barely hear you.
I don't have a microphone right now. Do you understand? I'm using my headphones.
Are you in your new apartment, or are you still?
I'm in my new apartment, but my desk that I want to use has not showed up yet. So I got a desk, but it's too short and it's crap, and I'm not keeping it, and it's cheap. So the new desk I'm getting is Tuesday. It should come on Tuesday, and then I'll have my microphone and my camera and everything back. Because every time I go to a stand-up, they're like, "Oh man, Devin, it's not the same when we don't see your microphone." Like that's how I recognize you. That's how I know you're here. I'm like, I don't know what to tell you. So next week.
A new room tour, like a new apartment room tour.
This ain't MTV Cribs. You don't get a tour. There's no. It's not.
You can on your YouTube, then we go watch.
I thought about it. Once it's ready, I don't want to do the whole maybe I'll record myself building the desk, maybe, but I like things done on YouTube. I don't like failing on YouTube. Like some people can do that, I can't. So when it's ready, right now it's just a bunch of boxes I gotta throw away for furniture.
This looks like not a new apartment. You look like a ready move out.
Oh, I'm destroying the environment. I've had so many boxes coming and going.
You move like a month, right? Or 3 weeks.
It's just me, so it takes longer.
Okay, so we're gonna choose next time topic. Ray, you pick so hard the problem. We're gonna.
No way.
I mean, sorting is hard, but it's like the most important thing you could probably learn in terms of the algorithms.
I mean, you guys implemented the harder solution. My solution was much more.
Okay, my solution is really good. We have best optimize the space complexity.
Well,
I'm not defending it.
Just don't understand the logic, and it's so beautiful. You find the perfect position of period noun. Your card solution don't have perfect position for period noun. You just put a period in the middle.
Oh my goodness. It all depends on how the numbers are arranged, your input. You don't know.
Please be honest. We are not smart enough to understand the code, because the logic of code is so complicated and we don't understand. But the way we work through the problem, how we find the perfect position of the period noun is so beautiful and optimized.
No.
Don't you agree, Adam?
So Jen, what's most important is your overall time complexity. That's what everyone in the interview is going to care about. They're going to ask you, what's your big O? If they're the same, they're the same. It doesn't matter.
First of all, what's most important is getting the working solution. Yeah. That's what's most important. Let's never forget that. So.
Wow. Okay, never mind. We're gonna find the next question.
Oh my goodness.
I
thank you.
wanted to do the merge sort, which is
Yeah,
more
I don't
optimal.
want to do that anymore. Okay, so it was
Duh!
look, it was so unfair. I did upon race request, I never did a hard question.
I actually wanted merge sort last week. I asked for merge sort, but you guys
I
said quick
spent
sort.
so much time energy to walk through 16 rounds and the perfect position of pivot now. Then you guys don't appreciate, and during the process, you guys was napping. My
Didn't
God,
even-
Who was
today,
napping?
bro, today I walked the whole day just to walk through all those pivot now. I have to walk through all the steps.
Jen, you said you promised not to.
But I'm not doing something anymore. Plus, I did so much effort. You guys just napping. It was.
Who's
Oh,
napping?
man.
Why are you napping?
If you are the one napping too, you don't follow.
I was coding my solution, testing my solution on the side. Well, you guys.
I did a quick sort whole day today, Saturday. Okay, weekend I just quick sort.
All right, so Bishesh wants to do a linked list.
And the pivot now. Jeez.
Okay, Bishesh said linked list.
Yeah.
What about a linked list?
Next time, bring some energy, please. Oh.
All right, Jen, pick a linked list. Since
Whoa,
that's what Bishesh wants.
Take it easy.
Okay, we can do that one. We can. I don't know if today you guys seen successful coaching call. Did you guys get this one? Remove duplicated.
Duplicate of what?
That's what I'm wondering. Just in general?
Remove duplicated from linked list.
Nope, we did not do that.
Great, we're gonna do this because this is easy. Look. That's good decision. And it's linked list.
Sounds good.
And this is very popular coding interview question, okay? So we're gonna do all those green before we do red. Look, red. This is the only red we did. Quick sort. Only red. Right.
And so it's good.
So next time, if you wanna choose the red question, you cannot sleep, and you're gonna turn on your camera for the whole time.
Goodness.
You can sleep when we do green, okay? It respect people's effort.
I don't know who you're talking to. I know I wasn't sleeping.
Selection sort. Because of Ray, I did a quick sort, and you guys just sleep. You was pissed. Okay, we're gonna.
What is the gray one? That is the hardest. The one to the right.
The black one is very hard. Red one is hard.
How hard can it be? Waterfall streams.
They are very hard.
Never ask how hard can it be.
Okay, let's say today we went through 16 steps. They're very hard, maybe 32 steps. If you guys don't sleep, I can try, you know. Okay, we're gonna do this one. So we decided.
What? Oh.
Remove duplicates from this linked list. It will be really good. Okay.
Cool.
Okay. So we're gonna wrap up this meeting, and I hope next time people bring some energy and not napping.
Hey, Devin, how soon are you going to push this to your YouTube channel?
Well, my computer is screaming right now, so maybe I'll push it. Maybe I'll just push these all tonight and just kill my computer. I'll try to push them all by Monday.
Cool. Yeah.
Thank you.
It's pretty sad. Everybody napping, only me. You can walk 60 steps.
Wow.
Okay.
I'm so sorry, Jennifer.
Okay, I'm gonna flip the file then at the end, you guys say this solution no good. How pissed I can feel.
I mean, if I had more time to look, I would have prepared an explanation for raise probably, but I didn't have time, so I went with what was in front of me.
Okay,
But
so
yeah, it's not your solution, Jim. It's okay.
thanks for the participation, Ashwin and Saddam. You guys understand the perfect position of pivot now. The people who napping, they will never understand and they never experience the exciting moment. Sorry. Okay, so we're gonna see you guys next Saturday, okay, for Link the List.
I don't regret missing last week anymore.
Huh?
Then I'm gonna have you code the perfect solution next week or another time, and you better remember it.
No, it's not perfect solution. It's perfect position of the pivot now.
Okay.
Perfect position of say that 5 times fast.
Okay, so I'm gonna end the call and zip the file and I'm gonna go have dinner. Okay? Bye.
Bye.
Saturday.
Devin, I'm gonna chat with you on the Slack.
See you, everyone.
Yes, chat with me, please.
On WordPress.
Bye,
Yes,
everyone.
bye.
All right,
Bye.
I'll take it.
All right.
Thank you.
Oh, these headphones off me. Oh, I gotta pee. Oh, man, I'm out of here. It is. This one here. Nigga. I was dying.
I have been suffering with migraine for years. Nurtec ODT has worked wonders for me. Don't take if allergic to Nurtec. The most common side effect is nausea. For more information, go to nurtec.com.
If you vape, you could be inhaling toxic metals into your lungs.
Okay, so as a laptop reviewer, I try my best to stay impartial. I don't have brand loyalties, I don't have preferences for one company over another. It really is, what is the best option available right now for someone looking to buy a new device? And I've been called an Apple fanboy in some of my videos, I've been called an Apple hater in some of my videos, sometimes both in the same video. But I want to have a conversation today about the Apple lineup, the M1 Apple Silicon based stuff. And this is good hardware. It's so good to the point where it's actually made it more difficult, more complex to purchase a new device for a lot of people. So I want to draw your attention to the base model MacBook, the $999 MacBook Air. So this is a device that has an amazing battery life, like 11 to 12 hours of real-world use. This is 40, maybe 50% longer than a competing Windows laptop of the same kind of battery size. And when it comes to performance, the M1 chips are weirdly capable. Even the fanless MacBook Air can keep up with some of the best stuff out there. It's a very energy efficient platform. And also the screen, like the MacBook Air screen, on a $999 device, you're getting high resolution, 400 nits, good color accuracy. That kind of spec does not appear on a $1,000 Windows laptop. You just don't get good screens like that at that price point. There are some hardware deficiencies though, like the MacBooks, they have a limited selection of ports right now. The screens have no touch capabilities and the bezel is thick on it. It's not a particularly nice looking or new looking device anymore. And there's very little user repairability on this device. But in terms of the fundamentals, the stuff that really matters when it comes to a laptop user, the MacBook